This is Indigo Pine. This was Clemson's entry for the Solar Decathlon, which we competed in last October. It was a 2-year process that Clemson competed against 16 other schools to build a completely solar-powered home. And we were rated on several areas, including architecture, engineering, affordability, and other things like that. This is the main porch of it. This is actually designed completely structurally independent from the home. So you could have a wraparound porch if you want, or the home that was in California actually had they had a ramp to be handicap accessible straight down. So this was designed completely separate from the house. It is also the only member of the home that used screws. There's no screws or nails used in the actual home, just stainless steel zip ties, and then the rivets on the paneling. But these screws here are the only section of the home that actually did have screws. Welcome to the inside of my lovely home. This chair actually shows a good representation of the construction method used throughout the design of the home. You can also see it around you in the walls. It was CNC cut off of sheets of plywood, and it was cut basically as a giant 3D puzzle piece. It just pops into place, and then you have stainless steel zip ties to hold it together in tension. And this actually is a durable home. It was rated to withstand the hurricane levels in South Carolina and also the earthquake levels in California. So it's actually a very durable home that was tested here in Clemson in our structures lab. There's actually no structural support on these inside walls. All of the structure is supported by the outside walls, and then our single box girder that runs down the middle of the building kind of acts like the spine of the building. And so what that allows us to do is the inside of the house is completely customizable. You can shift or move or rotate anything you want as you wanted. You could have one giant studio room if that's what you wanted. The floor goes from one end of the building to the other end as a single entity. So yeah, one of the underlining themes of this house was to maximize space in a limited amount of space that was given to us. So what we did was, it was designed to allow maximum storage space. And one way that we did that was, instead of having a typical wall which has a stud in between for the support and everything that takes up a lot of space, so instead it's actually just a single sheet of plywood, and you can actually see directly through it. But what there is there's cabinets on either side, so that acts as an acoustic barrier, and it also creates a barrier to hide all the electrical stuff. But what it does is it minimizes space and maximizes storage. So everything about this home was actually designed to be sustainable, down to the insulation. The insulation that we used throughout the house was actually recycled material. It was made of recycled blue jeans and paper products and other things like that. And that was actually the only insulation that we used throughout the entire house, along with the outside panels that also acted as an insulated barrier. But other than that, there was no other insulation. So as you can see here, the panels on these colorings are different, and what it does is the white panels reflect direct sunlight, so it won't be absorbed into the house as much. So during the summer, that's a very easy way to direct heat out of the house instead of being absorbed into the side of the house. But during the winter, you could interchange these panels with the darker ones, which actually absorb direct sunlight, and it would keep the heat within the house. And these panels are very easy, they're just riveted on. And so what you can do is you can just bust this rivet out, lift it up, take it off, put a new one on, and then pop it back in place. It's very simple. When we were taking down the house, we did all these in like 2 hours. So you can't see it here, but in the finished house, there was actually a lever system here, and what it did was, using these cables here, it controlled a flap in the ductwork, and it was a mechanical solution to a problem, so it didn't cost any electricity or any kind of energy. But what it did was it would direct airflow to specific rooms that you wanted. So the foundation of this home was built on CMU concrete blocks, and what we did in the design of that was some of them were actually rotated on their side. And what that allowed to do was it channeled airflow inside and underneath the house. Then the airflow is then directed to the HVAC system, and because the concrete blocks that would cool through the cool air, it actually helped to increase the functionability of the AC unit by pumping direct cool air into it. And so yeah, this is everything of the home. I hope you enjoyed it, and you can even charge your solar powered car here.